Welcome to the 12 May 2020 episode of IBM Developer Puget Sound. Topic Think 2020, Lab 1, Session 1221, Subtopic AI Fairness 360. From the previous video, you'll remember we set up a Jupyter Notebook in Watson Studio, and the notebook came from the B. Leonard DB3 Think 2020 repository on GitHub. We were working in Lab 1, and Lab 1 was detecting and mitigating bias using AI Fairness 360. After working through this, I realized this is not an introductory beginner's notebook. Certainly you could learn something by listening to this, but we've jumped right into the middle of a fairly advanced topic, and if you need a beginning introduction to Jupyter Notebooks, this is probably not the place. This toolkit is developed by IBM Research, and it can help examine, report, and mitigate discrimination and bias in machine learning models. As we'll be taking a look at specifically at adversarial debiasing. Scrolling down a little bit, we can see that there's some official links, and we should take a look at those. Also note that I've taken the liberty to pre-install the notebooks for these labs. So this is the AIF360 mybluemix.net website, and there's extensive documentation here that goes into depth, and I wanted to point out that you can join the Slack channel to ask that's the official place to ask. So the Slack is AIF360.slack.com. You can see that link in the lower left hand corner. And then to join the channel, there's also a request for invitation. Additionally, there's a Read the Docs site, an official Read the Docs site at AIF360.readthedocs.io, and I've already searched for the keywords for this lab, adversarial debiasing, and I've pulled up that page. So here we have the documentation for this particular function, and there's a reference that this function was based upon, and if you do a little Googling, you'll find this paper, Mitigating the Unwanted Biases. And if you scroll down a little bit, you see there's some definitions here. We speak of the concept of mitigating bias. So it says a predictor y hat satisfies demographic parity if y hat and z are independent. Of course, they define some of that stuff up here, where z is the protected variable. So naturally I had to do a little research, not being an expert in the field, and you may have to do some similar research. So for example, you might want to know what y-hat is, and if you Google y-hat, let's see here, right here, y with the little mark on the top is pronounced y-hat, and further you may need to brush up on your matrix math as well. So this is talking about projection matrices and hat matrix, and so you may want to take a look at well, gosh, sorry about all the scrolling. Could have started out here, right? Matrix math, and I was at the place I wanted to be originally, but I had to scroll up there. So well, what did I do here? So it says, talks about the matrix notation. It says matrices are usually uppercase letters, such as A in the examples above. And then the lowercase letters, like this, represent the entries in the matrix, like that. So A11 is an entry in matrix uppercase A. With that knowledge in hand, we'll switch to our Jupyter Notebooks that we created in the previous video and ran. We created it and ran it, and here you see the links to the website and to the documentation that we just looked at are also listed in the notebook. And remember this adversarial debiasing, and so there's some things that have to be done first, and I installed this, but then there were some warnings, and it asked for a downgraded package of TensorBoard and an upgrade for Pandas, so I did those before doing the install, and that got rid of the warnings. Depending on which notebook you have, that may vary. So here you can see they're doing a bunch of imports, and so I keyed in on the AIF360, so they're loading the data sets and some utility stuff, and then right here it says adversarial debiasing, and so instead of trying to it's like go line by line and understand every part of this, I just went straight to you can scroll around in here using the search function, just depending on your browser. And with my browser it was Control F. So there we're back to the beginning again. So here we imported this, and if we scroll down, I'm not sure why it doesn't. It says it's at 2. Oh, number 1 is the title at the top somewhere. So here's a case where you see we've selected this by the find function, and then debias equals false, and that's the plain model. And if I scroll down twice, the first time just puts us at right here, which is just a note, and then the second time down, ways down in the notebook, adversarial debiasing function is, or method is being used again. and in this case it's true, and they've labeled that the debiased model. Let's see what happens if we go down to 6. That's some more a note in the data. Let's go back to the research paper. And if we scroll down to the very bottom, we'll see that they're kind of in the conclusion area. They're providing some results. They have the without debiasing and with debiasing, and apparently it should get better with the debiasing. And I haven't read the paper closely enough to know which numbers are better, but overall we should, I'm guessing, and we'll check this in the notebook, but I'm guessing that our notebook should provide some kind of a result like this also. So if we switch back to the notebook and scroll down in the comparison, we have some train and test models. And then we have the privileged and unprivileged groups. So there's train and test in both unprivileged and privileged. If we scroll down to the answers here, we see that there's some results, and the results aren't in a confusion matrix like in the paper, but you can see that maybe they could have. There's without debiasing and with debiasing. And I'm going to switch back to the paper for just a second here so you can see that. So here you've got without debiasing and with debiasing. Uh-oh, I went the wrong way. Sorry. So we've got without debiasing and with debiasing, and then the data for each of those. And then they go through and print out some nice charts that show the improvement in the data. And so with that, I think hopefully that you found this interesting, and it's certainly not exhaustive, but and I'm not an expert in this field. I'm just reviewing this as a lab student, and if you want expert help, you could get that through the IBM Slack channel. Thank you for taking the time to look at this video, and I hope you'll have some time to look at future videos.